We have looked at an example involving diagnostic tests in the previous lecture. Today, we are going to build on that and bring in cost and profit. So let's take a minute to read the problem. Okay, so let's proceed step by step. The first thing would be to define the events carefully, as we always do. So let D be the event that the item is defective, and T is the test indicating the item is defective. So we are not using D plus and D minus and T plus and T minus as we did last time. We'll use more standard notations, D and D bar and T bar. So that gives us the partition of the sample space in terms of dt, d bar t, dt bar and d bar t bar. Now, for these four cases, we can find out using the information given, as before, the sensitivity and the specificity information, we can find out the probabilities of these four events in the partition. And if you do the algebra carefully, the numbers are as you see here. So I'm using basically some form of P of AB is P of A given B times P of B. So if you do it carefully, you would arrive at the four probabilities, and one good way to check that your answer is correct is add these four up and you should get the value of 1. Now, this is not the entire problem. The company takes decisions based on these test results. So let's look at those now. So if the test is positive, so it doesn't matter whether the item is defective or not, because the company only knows the test results. So if T is there, then the item doesn't get sold. It doesn't get shipped out. So that's true whether it's DT or D bar T. So the first two cases, the item is not sold and the income is 0. In the last two cases, when the test does not indicate the item is defective, actually the test indicates the item is okay, then it's shipped out. Now, if it's defective, then there's problem, because the income is the sale price, but eventually there will be penalties, so there's a lot of negative value there. And the ideal case, the one that the company always looks for, is the D bar T bar, and that is the item is sold and no problem. $1,000 is earned. So now let's look at the profit angle. So the profit is minus C0 plus I. So minus C0. C0 is the cost to manufacture and I is the income, which we listed the four possible cases. So let's interpret the problem as I is a random variable and it has four possible values and the four probabilities that are listed in the second column. So now we want to find the expected profit. So the expected profit, as we know that expectation is a linear operator, the constant just remains as it is, and the expected value of the income. The expected value of the income is the value times the corresponding probability. So that would be minus 500 for the manufacturing cost, that's always there, and then the four possibilities, the first two being 0 income and the third income being negative, and the fourth possibility has a positive income. So if you now do the algebra, you get an expected profit of $291.10.